Okay, guys, we're going to start with the first problems. We're going to go through pages 1 through 5, and we're going to start by sketching a piecewise function. If you notice, the first function is y equals x squared, but we want it for all values less than 0. So if you remember, x squared, y equals x squared has its vertex at 0, 0. Something. All right, guys, we had a technical difficulty, so we're back to problem number 1. X squared, if you remember, has its vertex at 0, 0. And if I graph it, it would be, if I put in points, when it's -1, it's 1. When it's 1, it's also 1. For -2, it's going to be 4. 1, 2, 3, 4. But since I'm interested only in values less than 0, I'm really not interested in the right-hand side of this. So I'm just going to go ahead and erase that point, and I'm going to graph my function. So we've graphed x squared less than or equal to 0. 1 plus square root of x, if you remember, starts at 0, and it looks like this. So if you don't recognize this, write it as y equals square root of x plus 1, which means you're going to move this 1 unit up. So you're going to move it 1 unit up, and it's going to be 3, 4, and 2. So there's your graph. It's greater than or equal to 0, so you want a dark circle there. And for your quadratic, you're going to have an open circle. And there is your piecewise function. Number 2. The best way to handle number 2 is to look and see your functions, reading it from left to right. This looks like a quadratic to me, and I'm going to check it when x is equal to -1. Is this -1? Yes. So this is a quadratic, so I'm looking for x squared negative, because it's been flipped over the x-axis, for all values of x less than, maybe equal to 0. So that's the first part. The second graph that I'm looking at, the function that I'm looking at, is a linear function, and it looks like it's y equals x. Its intercept is at 0, and its slope is 1 up and 1 over. So I'm going to look, and this is for all values of x greater than or equal to 0. So if I look through A, B, C, and D, which is not here, but we don't need it, notice that B corresponds with that problem. All right, for problem number 3, we're looking at x equals -3, so this is -3. Notice there's a jump. It jumps from here to here. So the first one is a jump discontinuity. At x equals 1, notice that both sides are going, they're up towards infinity, but they're not going to cross over 1. So this is called infinite discontinuity. And then the last one, we called it, if it's just one point, we call it point discontinuity. The answer key for the county calls it removable. So you should probably know both those two vocabularies. Looking at number 4, they've given you two piecewise functions, and they want to know where would be if it's continuous at x equals 5. So essentially what you want to do is, for it to be continuous, you need to have both of these continue at x equals 5. So cx plus 7, we're going to substitute x equals 5, so I'm going to have 5c plus 7. And then the second, x squared, when I substitute the 5 in, I should get 25. So I set these two equal to each other. And I solve for c. So subtract 7 from both sides. You're going to end up with 5c is equal to 18. Divide by 5. C comes out equal to 18 over 5. So the value of C, where it makes this continuous, is 18 over 5. Same thing again with number 5. You have 4x plus c. So x, you're going to substitute 11 for x, so you're going to get 4 times 11 plus c. And for 5x squared minus 2, you're going to substitute 11. So it's going to be 5 times 11 plus, minus 2. So we're going to set these equal to each other. So 44 plus c is equal to 55 minus 2. Subtract 44 from both sides of the equation. You're going to end up with c is equal to, this gives you 53. So 44 from 53 is going to be 9. So c is equal to 9. Okay, for number 6, it says which of the following is true about the function? So you're looking for the only statement that's true. If you remember, you need to make sure your denominator is never 0. So x minus 3, if I set that to equal to 0, it is undefined at x is equal to 3. Let's just look at that. So it says the function is continuous for all real number. I already know it's discontinuous at 3, so that doesn't count. That's not a correct answer. We're looking for the true statement. The function is discontinuous at x equals 3 only. That's a true statement. And this is false. And there's only one value that it is true. So the answer to this question is B. Number 7, remember that even functions are functions that are symmetric with respect to the y-axis. And when you're looking at this, you can see that it is a mirror image. If I fold this over the y-axis, it will match. So this is an even function. All right, looking at number 8, again, they're asking if it's even or odd function. So odd is when it's symmetric with respect to the origin, and this is obviously symmetric with respect to the origin, so this is an odd function. Number 9, we want to know whether each function below is odd, even, or neither. So you basically need to look at the each graph of the function. So if you look at sine, the sine function is odd. Also, the cube function is also odd. So this is an odd function. X squared minus 4, x squared, you drop it down 4 units. So it's symmetric with respect to the y-axis. So this is even. Cosine function is even, but 4x is an odd function, so this is neither. f of x is equal to x to the 2/3, which of the following is not true? Be careful with whether they're asking if it's true or not. For number 10, if you graph it, best thing to do is find points. So when x is equal to 0, y is equal to 0. When x is equal to -1, y is going to be 1. When x is equal to 1 is also 1. When x is equal to 8, I am going to have, it's going to be 4, and -8 is also going to be 4. When you graph this function, it looks something like this. Okay, so now we're going to, it's symmetric with respect to the y-axis, so that is true. It's an even function, that is also true. The range of the function is all real numbers. That means that both positive and negative, and if you notice, there's nothing underneath, so this is the false statement. Number 11, I'm sorry. We're looking at the domain. Domain is all values on the x-axis. So reading domain is always from left to right. So the first value you come across is 1, 2, 3, 4. And because it's defined, it's -4 through and 1, 2, 3. Or 1, 2, 3. Yeah. That's your domain. The problem is that you have a problem right here. You see that that's undefined. So I need to change this. It starts at -4, it goes to -2, union, but it's not defined at 2, so be careful with that bracket like I just did. And it starts at -2 and it ends at 3. Close bracket, defined. For range, we're looking at the y values, so it starts at -1, ends at 3. So your range is going to start at -1, but 3 has a hole there again, so that means it's undefined there, so you have to put a parentheses for the 3. And that completes pages 1 through 5.